Hello, I'm Sergio Dara. Good night, and I'm going to talk about fluids. The first one is the water distribution networks. The first one is the dead-end or tree network. It is suitable for all towns and cities that have not a definite pattern of its rows. This is the image. Due to the many quantity of dead ends, stagnation may occur, but it is cheap. The next one is the grid iron. It is suitable for cities having a definite pattern. The main branches are laid in rectangles, and the water is kept in constant movement, but the disadvantage is that the size pipe is not so can be calculated with precision. The next is the ring system. It is similar to the grid iron system, but the main branch is laid in the periphery, and the sub-branches branch out from the main branch, making rectangles. But in this case, you need professional workers to install or to lay the main branches. The last one is the radial system. In this one, the water is pumped into the distribution reservoirs, and then the sub-branches are laid radially towards the periphery. The gas distribution system is similar to the one of the dead end of the water, so it has no problems. The drain networks are three: the gravity system, the low pressure system, and the vacuum system. The gravity system takes advantage of the slope and the gravity of the earth, and the low pressure system and the vacuum system works with electricity.
For stage 1, we're going to give you an example of density. Density is equal to mass over volume. On this example of an object, we have an object with a mass of 0.48 kilograms and a volume of 2 cubic meters. The density is equal to 0.48 kilograms over 2 cubic meters. The density is equal to 0.24 kilograms over cubic meters.
Hi, good morning. My name is Diego and I'm going to talk about thermodynamics and heat. First of all, what is a heat source? It's any object that can use to derivate heat. It can be considered as a source of heat. We can have various examples like charcoal, petroleum, fossil fuels, even in a nuclear way. In the house, we have the wood. The wood we use to light up the chimney to produce heat in the house. In the industries and the companies, they use the fossil fuels and the electricity to produce enough power to make their chemical process and produce their products. In the environmental cooling, we have the natural ventilation. This can be the windows. They are used to moderate temperature and humidity. They also reduce the accumulation of moisture, dust, odors, and the bacteria. The heat exchanger is a device that is used to transfer the heat between two or more fluids. The first fluid transfers the heat to the second one, and the first one cools down. Finally, we have the atmospheric phenomenon. They are physical phenomena associated with the atmosphere. We have an example like clouds and auroras. The clouds are very important for the world. It's just to the cycle of water. Thank you for your attention.
For stage 2, we're going to give you an example of heat. Heat is equal to mass times a specific heat times the change in temperature. The example here of the object is of 28.42 kilograms and a specific heat of 2,800 joules over kilograms and a change in temperature of 36 Celsius degrees. We multiply the values and it gives you 2,864,736 joules.
In this video I want to explain some about electricity. We have the different methods to get electricity. Electricity for the steam is electric power, windmills, and solar power. In electricity for the steam, we have a power plants that generate electricity by burning fuels. The steam generated by the process makes spin a turbine that generates electricity. In hydroelectric power, we use the falling water to rotate the blades of a hydroelectric turbine to make electricity. Electric field is a measurable effect generated by any charged object. The electric field created by the charged object is the electric force between the object and the test charge divided by the magnitude of that test charge. Electric current is the total amount of charge passing through a wire over a period of time. In home, we have a different type of circuits, series and parallel.
You'll recall that series formations occur when resistors are connected along the same path, so they have the same current passing through each one. And parallel connections are when resistors are placed on wires that branch out from a single point, all having the same voltage drop across them.
On stage 3, we're going to use an example of the Ohm's law. The Ohm's law is equal to voltage equals current times resistance. We have a voltage of 13 volts, one resistance of 4 ohms, another resistance of 5 ohms, and we have to calculate the current. The current is equal to voltage over resistance. The resistance is equal to 1 over 1/4 plus 1/5, which equals to 2.22 ohms. The current is equal to the voltage, which is 13 volts over 2.22 ohms, which in turn equals to 5.85 amperes.
Hello, my name is Marlene Grimaldo, and I'm going to explain about waves, sounds, and optics. Sound sources are divided in two types: natural ones such as animals, the wind, or a flowing stream, and man-made such as airplanes, helicopters, or some home appliances. The sound is propagated by waves and always by a material mean. This means that at vacuum it can be propagated. Now, the speed of a sound is a term used to describe the speed of the sound waves passing through a material mean. And at sea level, under normal atmospheric conditions and at a temperature of 21 degrees Celsius, the speed of the sound is 344 meters per second. Now, the intensity level is different from the intensity, and it is measured in decibels. Why the decibels are taken as the unit for intensity level? This is related to how we perceive the sounds. How our ears perceive sounds can be more accurately described by the logarithm of the intensity rather than directly the intensity. To conclude, an optical device can create, manipulate, or measure some electromagnetic radiation, and it processes light waves to enhance an image for a clearer view. Thank you.
For stage 4, we are going to use the example of frequency. Frequency is equal to the velocity over wavelength. On this example, the wave has a wavelength of 3.7 meters and a velocity of 23 meters over second. The frequency is equal to 23 meters over second over 3.7 meters, which equals to 6.21 hertz.